Hello, everyone. Thank you for attending our virtual FRC camp hosted by the 1010 Thunderbirds team. I'm glad you guys could make it. And without further ado, let's get started.
So we're a team in the organization called FIRST, and FIRST stands for Inspiration and Recognition of Science and Technology. It's a global nonprofit that essentially prepares young people for the future through STEM and robotics programs, and it was founded in the 1980s. It inspires innovation and leadership in science and technology, and there are 3 age-based programs: FLL, FTC, and then FRC. We are an FRC team. Our team core values are shared with FIRST are gracious professionalism and cooperation. And FIRST is also supported by a global network and offers access to millions of dollars in scholarships.
All right, so our first part of the camp is going to be computer-aided design, or CAD, which will be led by Rishika.
So we'll first dive into essential 2D drawing skills like line, circle, rectangle, or other polygons. And we'll also look at modify commands like moving, copying, and trimming what we've already drawn. We'll also be looking at different types of coordinates that includes relative Cartesian, relative polar, as well as absolute coordinates. And we'll also cover how to organize your drawing using layers and object properties. And we'll finish with a brief walkthrough of exporting and printing your work as a PDF. I'll also be doing a quick demonstration of a simple design on AutoCAD and give you guys some quick resources for continued learning and also answer any questions. So first we have the interface. So the key elements in the interface are the ribbon, command line, navigation bar, and status. So the ribbon is essentially where you find all your drawing tools, modification tools, annotation layers, and it's organized into tabs and panels for quick access to tools. There is also the command line, which allows you to type commands, see options, and receive feedback from AutoCAD, which allows you to do the entire program and do any function you would like without actually using your touchpad. You also have a navigation bar for you to navigate around your design. You can zoom, pan, and view, which is helpful even in 2D. AutoCAD does have 3D options, but in this webinar, I'll just be covering the basic 2D functions. There's also a status bar where you can control how you interact with the design. So there's toggles for snapping your cursor to specific points on the grid, having your grid visible. You also have ortho, object snap, and there's obviously more options. So what we're going to be covering next is coordinate input methods. So when you are designing something on AutoCAD 2D, there are basically coordinates that you can choose to have points in your polygons or lines or whatever you are drawing. And there are 3 types of coordinates that you can use in 2D AutoCAD. There are absolute coordinates where you enter coordinates like the ones given to place a point at that exact XY location from the origin. You also have relative Cartesian coordinates, which is probably the most useful when it comes to making a design. In this one, you put you do at with the coordinates to place a point relative to the last one. As you can see, the picture that is on this slide is actually an example of relative Cartesian. It's a good practice template if you want to try to figure out how to navigate Cartesian coordinates by yourself, because it has all the functions that you need to use to create this drawing. Finally, you have relative polar coordinates, which really just uses the distance and the angle to draw lines at specific angles and lengths. Like the example given, at 10 less than 45, which means it would be a length of 10 at a 45-degree angle. So the main part of 2D AutoCAD is essentially making a design, which obviously includes having different drawing functions. So there are a lot of drawing functions that you can use, but I'll be going over the main ones. So you have a line, which is a simple line between 2 XY coordinates, and then you also have a polyline, which is a hybrid line function that can have multiple lines in the same shape. That means that for a line function, you will select just a singular line, but for polyline, if you select one line, you'll be selecting the entirety of what you do with the polyline function. There's also a circle. You have 5 different ways that you can draw circles. There's center radius, center diameter, 2-point, 3-point, tan radius, and tan. Depending on what you need to draw the circle for, you might change which one you're using. There are 11 different ways to draw arcs, and I haven't listed all of them on this slide, but you have 3-point, start, center, end, start, center, angle, start, center, length, and then there's 7 more. For polygon, it's a little bit more self-explanatory. You just choose the number of sides you want, or if you want a rectangle, you can choose that as well. There's a separate function just for that. You choose the amount of sides you want and the center point for where you want the polygon. If the polygon is inside a circle, you can also choose if you want it inscribed in the circle or circumscribed. You also have grid snap and object settings, which makes navigating through the design process of AutoCAD 2D a lot simpler and easier. So you have grid and snap. So the grid display, which you can use, which the shortcut is F7, it shows a reference grid in the drawing area, and otherwise the grid will not be visible default. You also have the snap mode, which locks cursor movement to set intervals, making alignment easier. You can change the snap mode for X and Y, so X, Y coordinates can be at different lengths. To access these, you just right-click on the grid or snap buttons in the status bar to open drafting settings. And O-snap is basically where you choose where your cursor can also snap to on the basis of shapes that you already have in your design. So you can have it on endpoints, midpoints, intersections between two shapes, perpendicular lines, centers, nodes, quadrants. There's a lot of different options that you can view. And you also it's important to turn off unnecessary O-snap modes to prevent snapping to unintended points, which can get a bit frustrating when you're making your design. We also have modify commands. So you already know how to create simple drawings in your design for AutoCAD. So modify commands essentially modify what you already have. So one of the most basic ones is move, which shifts one object from one location to another. You essentially choose a starting point and an end point, and based on the relative distance between those points, it moves the object. You can also duplicate selected objects using the copy function, and rotate objects around a base point using a rotation function. Also input the angle that you want the object to rotate at. You can also trim, which cuts off parts of objects that extend past the boundary, and contrary to that, you can also extend certain objects to meet a boundary. You can also offset, which means creating parallel copies at a specified distance, and you can also create mirrored copies of objects using the mirror function along a set line. Finally, you also have layer and object properties. So layers are really important, especially when you have more complex designs, such as a floor plan. It helps you keep your drawing organized by assigning objects to different layers, and through this you can control color, line type, line weight, and visibility through layers. As you can see in the image here, if you, for example, click the light bulb off, you will no longer be able to see the layer, and you can also lock layers to ensure that you won't be able to edit them while the lock is on. So when you make your layers, you generally want to use clear descriptive names, like using underscores, and making sure that you don't get confused between them. It's also important to assign different colors to each layer for quick identification, and you can also use a match prop command to copy layer and object properties from one object to another. Once you have your design, you generally want to export and print it as a PDF. And for that, you use the plot command. The image on the slide is very blurry, but it's mainly self-explanatory. You select DVG to PDF as a printer or plotter, and then you choose the paper size and plot area. You can also set the appropriate plot scale and plot style, and then you click preview to check the result before printing. So I'm going to be demonstrating how to draw this simple design. If you want to follow along, here's a QR code to a website, which also has steps. I won't be following the exact steps on the website because it has a few more complicated functions that I haven't covered in this slide show. So this is the design we're going to be making. I have AutoCAD open on my laptop. First thing I'm going to do is create a new design page. So looking at this, you can see that the length between the circles is 100, and one circle is 16 in radius and the other is 15. What I'm going to do first is I'm going to click on circle. And actually, I'll edit my snap features first. You click on snap here, you go to snap settings, and I have it at 0.5 right now. I'm going to change it to 1 because I don't need it to be that precise with this drawing. It automatically equalizes X and Y spacing. You can also turn that off if you want it to be different. And if you go to object snap, you can choose what points of an object you want your cursor to snap at. So I'm also going to choose midpoint and perpendicular, as well as tangent. So to start this off, I'm going to start with a center radius circle, and I'm going to start it at a random point here. For the radius, I'm going to put 16 since that's the radius that was given. I click enter and it creates a circle with a 16-inch radius, or whatever unit I have set. Using the navigation bar, I can move around the design. I can see that the distance between the center of the first circle and the second circle is 100. So I'll create a line starting here and input 100. So now I know that's going to be the center of the second circle. And the second circle will be 15 in radius. Now that we have that, we can see that there's a pentagon in the first circle and a hexagon in the second one. I can click on the polygon feature over here and click on polygon. I have to enter the number of slices, that would be 5 since it's a pentagon. And since the center feature is there, I can click the center of the circle, inscribe the circle, and that would be a radius of 10. I'm going to do the same for this one, except it's going to be 6 slides. Inscribe in circle, and it's also going to be 10. Now I'm going to go ahead with the trim tool, and I'll trim the parts of the line that aren't necessary right now. Now you have this, but we also need to figure out how to create this middle part between the two ends of the wrench. For this, what we're going to use is an offset tool. So for the offset distance, it's 11, but since we have this line going through the middle, we want it to be 5.5. Click the object you want to offset, and then choose a side. The settings stay, so you just choose it at both sides. And now I'm gonna trim this, and the extent tool, but it's fine. I'm gonna put in a circle. So we're gonna be putting in a tan radius circle, since we know that the radius of the arcs that are given at the ends of the middle bar of the wrench connecting to the circles is 47 to 23. For the first tangent on the circle, we're going to choose a tangent on the circle itself and a tangent on the line. And the radius of the circle would be 47. You would go into trim and trim the rest of the circle, so you have this arc here, and then trim the end of that line, so you have an arc going that way. You copy the same steps for the other side of that part. 47, go to trim. And then you do the same thing with the other side, except it's going to be with a radius of 23. And then I'll trim it all at once. And just like that, you can easily create a wrench with this design in AutoCAD. So that's the only design I had planned to show, but I've also had some. Oh, this is also like a step guide for downloading AutoCAD if you haven't already. I recommend taking a screenshot of this, and it's quite a few steps, and it generally takes about an hour or so for it to fully download. And if you want to learn more, I definitely recommend checking out these websites. Autodesk Learn and CAD Tutor are probably my favorites. They have really good forums and like a lot of tutorials and guides. And they help with like all types of AutoCAD. It doesn't generally just go for AutoCAD 2D. You can also use these YouTube channels. They also have really good step-by-step tutorials, and Lazy Architecto has really good, easy to follow tutorials with practical projects.
Thank you, Rishika, for sharing your CAD information. So now we'll be moving on to the virtual FRC camp, which will be led by me and Ishan. So first of all, here's a little outline of what we're going to go over, which is just a very basic rudimentary intro to Java, and then we'll be getting into more FRC specific Java for the drivetrain, which we will demonstrate later with Ishan. All right, part 1 of Java, variables. This is probably a very, very, very basic part of actually programming in general, right? So you can use it to basically hold values that you want to represent in your code. And I've got some examples down here. So there are different types of variables like the string, integer, float, and Boolean. The integer is literally just a number. very basic. The Boolean, it's either going to be true or false. The string, just a string. You can also use numbers in your strings. As long as they're in quotation marks, they are considered a string. You can also use arithmetic with variables. So for example, on line 4, we got a result variable, an integer, and we are multiplying the number 4 by some var name, which was from line 1, a value of 4. 4 times 4 is 16. So when we print it out using system.out.print, it's going to return 16. For classes and objects, these are a little bit bigger. They basically encompass different kinds of values and methods. So in this example, we've got a class. This is how you declare a class. The class implementation will not be shown. It'll be shown later. And when you want to create an object that's from this class, you would just declare as the type some class, which is the class name, the object name equals new some class, which you're creating a new object of this class. Now, when you want to call a method on that object, you're just going to use the dot method, which is where you put your object name, you put a dot, and then you call the method with parentheses. Some methods do have arguments or parameters. Those will be the values that you put in between the parentheses here. So here's an example of a typical class with objects. We have a public class called car. These are the attributes which basically describe the objects that you create under the class car. This is the constructor. This is basically how you create the objects. It's the blueprint that an object would follow when you're creating an object under this class. So the arguments, we got a brand, a model, and a color as the arguments. And when you're setting the object, they're going to be declared using this dot, which basically means the brand, model, color, and speed of the attributes inside the class are going to be set to the arguments that you pass through when you're calling the constructor to make a new object. We have 3 different methods here. First method is just incrementing the speed of the class by an amount that the user passes through. Second one is just returning the speed. So if you want to get it for any reason, maybe you're trying to do arithmetic with that speed, you just call this method, because the information here is private, which means you cannot directly access it. The user cannot directly access it, which means you would have to call this method to get that speed. The second one is just displaying the info from the attributes. So if you wanted to print out all the information about your car, your object from this car class, you would use the display info method, which will just print out the brand, model, color, and speed of that car object. And this is kind of our main method here. We've got line 35 where we create a new object of the car class. Here are our arguments. We've got a brand Toyota, a model of Camry, and a red color. And we're calling all of these methods here just to display what happens. So on the next slide, highlighted there is the main method. And there's no output here because we aren't returning anything to the user's terminal or screen or whatever. There is an output when we do the display method, the display info method, where we have the brand, model, color, and speed printed out. So we have the variables here, the private variables, and taken from the arguments that we inputted earlier, they are the Toyota, Camry, and red, and a speed of 0 because we haven't done anything with the speed yet. However, when we accelerate it on line 41, that tells the program to increase the speed or increment it by 20. So next time when we print out the speed, we get the speed and then we print it, it'll return 20. And so next time we display the info, it'll have an updated speed of 20, and everything else is the same because we didn't change anything else. Some extra resources that I found to be pretty useful when I was learning Java were W3 Schools, which is basically just a big data center for different kinds of Java. And it's very easy to use. It's like Google, kind of a mini Google, but for programming. If you need a specific method or syntax for Java, you can just go on W3 Schools and find it. See, it's awesome. It's paired with College Board, so if you're taking AP Computer Science, it's very useful. I used it in my class, and it teaches you basically the basics of Java that you would also need for AP CSA. And CodingBat has a lot of practices. I used this a lot of the time when I was taking the AP class, and it basically helps me understand the syntax of Java. And so the next time that I use it, I understood if there were issues in my code and how to solve them.
Okay, so now that you've learned the basics of Java, we're going to move on to the robotics aspect. So we're going to start off with learning the parts you need to program because there's a huge connection between what you're programming and then the specific parts that the code is going to be inputted into. So we're going to be learning about something called motors, which has gears in it, so that's going to control the actual movement of the robot, and motor controllers, which are essentially like a mini brain for those motors. So we're going to learn how to configure each of those four motors, instruct them on what to do when they're called upon, and configure the navx, which is essentially the main brain for all of the movement and all of the commands, not just movement. And we're going to be using navx as our brain today, and also how to instruct the joystick and how to tether it with our robot so we can use that to control how the robot moves during teleop or manual drive. Okay, so first, these are the packages that we're going to need. So starting off with timed robot. Timed robot is essentially just a template, just like time skeleton or anything else that's available on the WPI library for FRC. Preferably for beginners, it's better to use a time skeleton or time robot. And then we have Smart Dashboard. Now, Smart Dashboard is optional, but it's up to you. There's a default FRC Drive Station dashboard, but you can also use Smart Dashboard for just to customize the way it looks and additional flexibility, basically. And then you have AHRS from Studica, which is essentially the class that has all the movement functions that's needed for the navx that we're going to program. And then we have Spark Max, which is from Rev Robotics, and that's just a brand of motor controllers that we're going to be using. So the next few imports are all about Spark Max. So Spark Max configuration, Spark base configuration item load is basically when the robot's stationary, there's a separate package for that for some reason. And then you have persist mode and reset mode, which are just different modes of the robot during different times. And then you have a package for determining the motor type, which is brushed and brushless. We're mostly going to be using brush, so that's just the way the motor's configured. And then we have a package for a controller. We're going to be using an Xbox controller, but you may use any type that just has two joysticks or whichever you're comfortable with. And then we have a timer package and a USB camera. The last three are all optional. We don't necessarily need them. The camera is just for better vision on the field. If there are too many obstacles and if your robot's on the other side, you won't be able to see exactly where you are, and this could cause penalties and all kinds of disadvantages. So camera is just optional but useful. So these are the two parts that we're mainly going to be focusing on. The thing on the left is a motor. It's a CAN motor. It's the default motor you get when ordering a starter kit. And on the right side is our SparkMax motor controller. Okay, so starting off with the code, obviously you're going to have to open your class of a time robot and then configure each of your drivetrain motors, or in this case your SparkMaxes, to a motor port. So you're going to have to tell which SparkMax goes to which motor and the number of that port. And on the right side you have brushed, like I mentioned before, is the type of configuration for your motor, but it's for us we're going to be using brushed. And naming conventions wise, it really it's preferable to use very clear naming conventions. So left front, that's your left side, front motor, left rear, your right side, front and rear, and an intake motor. We're not going to be focusing on that. That's just an additional motor if you have another subsystem that you need to program. But essentially, it follows the same code as your drivetrain. Okay, next we have configuring our joysticks. So we need to initialize them first. So we're going to initialize two joysticks in this case, but that's again optional. We can do one or two. And then we have calling our AHRS library, which, like I mentioned before, is just a package that has all the functions that needs to tell the Navix how big the robot is, how much it's going to move, when to stop, and all of that. And then at the bottom, we have a SparkMax configuration. So earlier we set which SparkMax is going to go to which motor and its port number into global configuration so that they are not constrained to a single class but can be used anywhere. And we name these as right leader and right follower and left follower. Reason being because the motor in the front and the respective SparkMax motor is going to be the essentially the leader, in which the motor behind it is going to follow the same commands. So there's no we don't have to separately tell each motor what to do, and we're not going to have any issues and discrepancies between those motors. And going specifically into each of the configurations, we need to make sure that we set a proper limit, because for CAN motors that we're using, it can go up to, I believe, 1200 RPM, which is too much for a basic drivetrain. So we're gonna set it to 50%, and then idle mode is essentially going to be telling the robot that when there are no commands given and when we're not calling upon any of the movement, it's gonna stay on brake and it's not gonna move. And we do that for every single one of these configurations, so every follower and leader. We configure our motors to each of those spark maxes. So we've already told each spark max, gave it specific speed limits, gave it what to do when we're not really when no commands are given, and now we configure each of the motors that we coded before to these spark maxes. And there's another mode called persist mode, which is essentially similar to idle, and we set the same parameters as what we gave those spark maxes, and we tell them that these are the ones going to be applied to their respective motors. And below we have an AHRS command. So essentially that's just initializing the Navex chip or board. Okay, first line, there is a function called yaw, which is essentially telling it, or it holds the position of the robot. So it holds the diameter, or like the dimensions of the robot, how lengthy it is, its width, its height, and keeping all of these dimensions in mind, it tells your Navix which direction it's supposed to go when called upon, and that's a specific function. And then you have some math underneath, so we're just coding individual commands. So if it's gonna drive forward, how long does it need to go, what the target distance is, and we're just initializing what type of number the target distance is. So it's a double. Always make sure any of your values are a double, because then you get to extend it to decimal places, and we need to be as precise as possible. So once we have our target distance, we initialize it to another variable, and then we use that to sort of tell how far or what the limits are when you push your joystick to the front, and what speed it needs to go. And if we're going to turn it to either of the sides, we need to tell it at what speed and direction. And otherwise, we need to tell it to stop and stay um, in like a stationary mode otherwise. Okay, so now starting with the override command, that's another class called teleop periodic. So essentially that's a built-in class you'll get with any template you choose. And the teleop periodic essentially tells the robot that every single time the joystick gives you a command, you have to follow it. And that's just not once, it's every single time. This is why the joystick commands and any drivetrain commands come under teleop periodic, not under teleop init, which is initialize it. Please don't confuse that. And yeah, so now we set each of our joysticks. So there's a double forward, so that's essentially the left side joystick on your controller, which goes front and back, and you can set the right side for rotation, which is to go left and right. You can have a single joystick to do both, however, it's not that preferable, but then again, it's up to you. And then you have different directions. So left front would be your forward and a positive rotation, so that would turn to the right. and a right front would be a forward and a negative rotation, so that would essentially turn to the left. And that's all. Thank you so much for joining our virtual webinar. We hope you found this really informational and interesting. If you guys have any questions, you have our email and contact info. So, yeah, thank you so much for your time.